All right. Yeah, I did a bunch of training. First let me pull up the notes because I'm thinking of like I titled this stream min max or no alpha beta uh detour. So like yeah, I'm taking a break from all the alpha zero approach and just going back to like I mean the first version of a bot I attempted to make did use this minimax thing. So like I'm basically redoing that except like kind of doing it all over again as more of a, I guess, detour and also like let me try pull this up. Yep. Okay. So yeah. So like one thing I was thinking of was using policy gradients or something, and just kind of like using policy gradient to like first of all like create like this kind of yeah like wait well actually let's just take it from the top. I wrote some notes on June 4th, so 2 days ago. Because like my training like again like not much progress is really being made. Yeah, like I've been running a bunch of training, but it takes like it takes so long to run. It's just yeah, so I don't think that like what I'm doing right, what I've done is feasible. So anyways, one thing I was thinking of is like first of all, like I realized like my prior notes I completely like overlooked, or I think I overlooked, I'm not sure. No, I didn't rewrite. I didn't put it in here, but I missed this. I missed a bullet point in this thing, or maybe not an alternative, but like yeah, like I should try a different net. Like one thing I was thinking of is like when we're kind of we have like the value in the policy heads. Like right now, like what Connect Four is doing, which we've done. Connect Four is like both the policy and the value head. Like they share all the other common layers. Like they share everything except like it's like basically fully sequential model. At the very end, there's a split. So like one idea is to like kind of like push the split in a bit further. So like the value and policy paths could diverge a bit earlier. So like they both would have some depth to them, like between the output heads and the value and policy output heads, and like the point of like splitting, like kind of add some depth in between. Maybe instead of after the flattening, we can split the existing. We can split and like existing we can split and like existing policy head. So basically leave, I think this meant leave, and leave existing policy head the same, but the value head would instead have its own dense layer after flattening. So the idea is that the output heads don't share everything with each other. Yeah, that's the crucial idea. But instead, like they diverge a bit earlier. Instead, diverge not at the very end, but like a bit before, so they can have their own extra depth. And then also use a ResNet like AlphaZero and Lila, which is a chess is kind of like an open source like distributed like a chess like the community basically kind of chess community like or chess engine like some basically it's a group effort where like they basically kind of re-implemented AlphaZero from scratch, and like it's thought to have surpassed AlphaZero a long time ago, and like they use a different like they don't use like a simple convolutional neural network. Like there's like a different architecture. It's called like a ResNet, which I don't really know much of, so I'll have to look into that. So those are like kind of like two things. Basically, they boil down to different net architecture. Like I could literally just use the same one that like Lila and AlphaZero do, and just adapt it to my game. As in the inputs and outputs would be different for BumperCoin specific, but all the intermediate stuff like the residual towers, everything would just be the same. And then that's in fact let me just draw what I mean by this. Let's pull up a whiteboard. Oh yeah, see this? I just added a link in the homepage. Also one to like a site that I'm building from. Anyways, the point is that like right now, like you can click this and you can play a really bad bot. I haven't uploaded the latest copy of the weights, but there's no change. And notice it's super laggy, right? Like another point, like yeah, see it took 530 ticks to make a move. Again, 60 ticks per second, that's like what, like 9 seconds or something before for the first move. Everything else is kind of fine, and the king is just being stupid. So this is a really kind of terrible bot. So like I know that the Minimax bot I wrote a few years ago is actually better than this. So like maybe I should just kind of like recreate that. Oh yeah, and the other thing is like this thing right now, like it's 530 ticks, and like if you look at the network calls, like what's happening is like see this like this get right here, this fetch. If you look at the, wait, let me just restart this. So you see how this is kind of like stalling, like no, wait, what? Like you see how like it took like, yeah, 9.51 seconds to like, to receive all the weights because such a huge file. Like how big, anyways, the point is that like, this is a very big response, and one thing is like it's saying 200, it should be saying 304, like not modified. So I'm a bit confused. So one thing I was thinking of doing actually is like, and also like when I pushed it like locally to my like the Git server, like which I'm using, which is kind of hosting my project, the private repo. Like it basically kind of complained that I'm going over. It complained that I'm kind of like I'm the band, or basically like I want to keep memory. I don't want to upload the weights to my site, so I'm thinking I could like upload these weights, the weights.bin, like the binary, like somewhere else actually, and then hopefully that could return free. Like basically like a lot of time is being wasted in the initial like 600, like 663 is like, wait, what's 9 times 7? 63, right? Wait, no, that's 63. No. What is, okay, let's just round this down from 617 to 600. So then 60 ticks per second is 1 second. So 600 ticks is 10 seconds. So like the first move takes 10 seconds. So like, first of all, we shouldn't be re-downloading the weights every single time. Instead, it should be cached. Or I think like you can also like store the model inside local storage or IndexedDB or something. I believe like TFJS has that thing too. Yeah, load model node from browser, obviously. Yeah, you see how like there's IndexedDB and local storage. So I could kind of like have something like this, and maybe not only store like in local storage the actual model, but I could store like a version number or like a git hash or something. And then like the page could come with its own like git hash, and if these two match, you can just kind of pull it from local, or else you just kind of re-download it, or like use the 304 not modified, which I thought Express automatically does. Like, but anyways, I don't know. I'm not sure. I have to look into that, where the first move is super slow. Also, we should warm up the neural net by passing it some dummy information like zeros or something, just to like, yeah, just warm it up, prime it. So yeah, as you can see, the bot, I've been doing nothing. The bot's just floundering about, not really making any progress. So that's kind of why like motivations, like, you know what, let's just at least like ship something, you know? So like just kind of like how like in Connect 4, like what we have, Connect 4, like how we have like some menu where we can like select number of simulations or something, like some kind of customization. Similarly, like maybe we could have like something on the side, like some panel, like for example, like we have like a map editor in BumperCoins. Well, like you see how like there's a panel where you can kind of like design your own like kind of, and like give it a name and whatever. Like there's like this little panel right here, like with some drop downs. Like right now we can like kind of like, the wind is like not fixed, but we can, or it is fixed, where it's like kind of units of some number. We kind of change that to no, and then we can kind of get a nice smooth thing. Whereas we're kind of like pinning it in certain discrete intervals, like it's more kind of snaps to some locations. And like we have like, all these customization options and stuff, and then like validate or whatever. And like we have all these kind of like options. Like if we remove the king coin or whatever, then validate, it'll say like, yeah, there's too few kings or whatever. Like we have some stuff going on here. So what I'm saying is that like we could like kind of like create like a bot strategy. Like should we use alpha 0 or should we use the minimax AlphaBeta, like some, and we can like do some customizations and whatnot. Like we'll let the person select their own bot, and if they choose alpha 0, they can like tune how many MCTS simulations they're running. And if they're doing AlphaBeta, they can like tune like the search depth or something, like, so yeah. So anyways, that's that. Yeah, so then what I'm thinking of right now, also like I'm not really making much progress in Alpha 0 training right now, so that's also why I think like let's just like kind of recreate the weak AI that uses minimax, and then kind of like maybe we can even use that to inform our neural net. So recreate this simpler, no energy considerations. Okay, can reuse some heart featured. I won't look at. I'll just kind of do it from scratch. Then have separate policy. And the point is that I was thinking like maybe like we could use policy gradient and like basically like train a policy network. Like we can use vanilla reinforce to just kind of like we can create a weak AI, and then we can kind of train a policy network to play against this AI, and basically like you use a policy gradient approach to kind of like improve our policy. By improve, I mean kind of optimize it to like be able to beat the AI, at least like the weak AI. So it's kind of like a bootstrapping process where like it's kind of similar to like super like the idea is like we're kind of like rather than having like a dummy policy network that's kind of giving you garbage outputs, like kind of train it a little bit and then kind of use that as a starting point. And maybe like it would do self-play policy gradient instead of alpha zero entirely, like just straight up policy and like no value, like no Q values, like just a vanilla. I mean, just a policy gradients entirely. But yeah, I have to like kind of relearn this RL stuff. Like I remember like kind of like when I looked at the derivation of like the policy gradient thing, like the expectations and like I remember like there was like a log trick or something. Like you kind of like use the fact that the derivative of like it's like you used to do something like really kind of weird, like funny, like it's like you're kind of like doing like PF like let's call this like I don't know, just the weights, or I think theta is what they call it, like times like let's call this the reward. Like again, like anyways, if you're following like some trajectory, like you're just kind of like playing, then like, and if you're kind of like doing that, like, and of course you're summing this for like you're summing this over all the like you're summing this for all the reward, all the steps you get some reward, like you're summing it for everything, then like it does, there's like this little technique you can do, like we have basically we want to basically like do like d of like this, we want to like kind of differentiate this thing right here, let's call this like this basically gives you all the rewards, and like when you kind of differentiate this, you do this kind of like finicky thing where you kind of like rewrite this thing right here, where you kind of rewrite this as like times 1, where it's like this thing divided by itself, and then when you're differentiating like this with respect to like, the point is that like somewhere along the lines, like if you're trying to like differentiate like this thing, like let's call this like whatever you're trying to optimize, like the reward thing, I think that they call it J or something like that, and like if you want to kind of like do differentiate that with respect to like P of theta, like P is like P is I guess like the probability of like being like, let's just say like sum over states, or I think it'll technically state action or whatever, like sum over like the state actions of like the point is that like you're basically kind of like computing this expectation, like let's say R like R of I or whatever, some I plus 1, something like that, where it's like you're kind of like summing over all the rewards and like the probability of getting the reward, so it's like a random variable and you're computing the expectation when you're kind of differentiating this, like, because like this policy, like basically like this term, the probability of like being in getting this reward is like it's a function of theta, because like you have to follow a policy and like that policy gives you those rewards, so like a better policy would like give you like more of like, it's like you get like in one time step you get like 1 reward, then like 0, then like 0.1, and then like 800 or like 8,000 over 9,000, and like you get like 2 or something, or like 002 or whatever, like so some random like trajectory where you get these rewards, then like this is a pretty significant one. So like whatever kind of like going from here to here, like you would kind of tune the policy more to kind of like get that hit. So like it's kind of like in the like when you're doing gradient descent on it, which is why we're taking the derivative. So like that's kind of the motivation behind like why we're differentiating with theta, because we're trying to like theta is the weights of our kind of our or policy. I guess they call it pi, but like the point is, wait, what is the point? Where am I going with this? Like, there's like this like little trick which you do. The point is that like I need to relearn or like like kind of yeah just refamiliarize myself with this stuff because like there's like this technique which is done where like you kind of rewrite this as like well p prime of theta, and like this apparently like you kind of do this very kind of weird technique where like you kind of take this and then you kind of like divide by like p of theta, right? And hear me out. You also multiply by that, like, which is literally just the same thing, except you can basically take this thing, like this whole thing right here, and you can kind of like just say, you know what, this is the same thing. You introduce a log term, like this whole thing basically becomes like p prime of like log of like theta, and like this step right here is a bit mysterious to me. And then like this kind of like rewriting as expectation type thing, and like you can end up like kind of only focusing on like this term right here because like vanilla like reinforced basically is like it's like a Monte Carlo kind of algorithm where like there are a bunch of trajectories. Like you have a policy, you just kind of follow your policy, initially bullshit policy. You just get the rewards and then you kind of like do the update steps, and then you kind of like do a trajectory, and then you kind of like it's like yeah, you feel like the point is that the like if you just like kind of sample a bunch, like Monte Carlo is like kind of like just sampling, like you just sample like a bunch of these trajectories, and like you get these like kind of rewards, and then you kind of tune and you use that to kind of like gradient, like you kind of you just it's a policy gradient, like your policy is like the policy you're following in your trajectory, and then you kind of like use the rewards to kind of inform the policy, and you get a better policy. You take those trajectories, and like it just keeps happening, and you keep like iteratively like kind of refining and like improving your policy basically. Like you're directly working with the policy itself, like you're so it's kind of like it's a whole different approach from like value-based approaches. But anyways, the point is that like this notion of like this works because like you know like it's like ln of x, like when you're kind of like differentiating that like with respect to x, like that basically becomes 1 over x. So like if you're kind of like doing the chain rule, then like this whole thing is basically like that, because like if you do this, then that would be 1 over like that would be like 1 over, or sorry, no not the log goes over here. Like but like the point is that like there's this like little log trick that's done which made me a bit uncomfortable, and like it's like a nifty way of like kind of like putting the probability like taking this derivative and like kind of like sticking out like a probability term to kind of make it an expectation, and then be like, you know what, since the expectation, then just kind of like all these kind of trajectories, like we can just take any one and just kind of like I have to review it, but the whole point is like kind of, and again like this whole p stuff, like when I say p, I guess it's probability, but like this probability is kind of like as a result of taking the policy. So it's like the probability that you get some reward at some state k is like from all the steps, like from 0 to like k minus 1 or k or whatever, like all those previous steps you have to take to get there to begin with. And like how did you get there? By sampling from the policy. So it's all kind of a function of policy based. Anyways, the point is I have to review that, but what I'm thinking is like I could kind of like perhaps like look into policy gradients again. And I did, I mean, not again, like, yeah, I mean, learn the theory again, and then like just perhaps like create the weak AI, and then kind of like use policy gradient or something, like somehow like kind of try to bootstrap off of a weak AI as well. At the very least, and this is kind of what I'm going to try to do today, or maybe like next few streams, is try to like provide the player the option to select which bot to play in case our deep learning bots don't materialize. So at least give the player something to work with. And then of course there's the traditional finite state machine approaches, which are just basically just ifs and else's. Like there's not, it's just hard coded, and like it's the least appealing option to me, because at least like with AlphaBeta and like Monte Carlo tree search with AlphaZero, like there's some depth. Like you are kind of, it's a more general, more abstract class of solutions that can generalize to other games, 2-player or as a zero-sum games, as opposed to like you know, this stuff. They're just hard coded for one game. So anyways, like it needs lots of domain knowledge. Whereas, I mean, I guess AlphaBeta, also the heuristic function, needs some domain knowledge too. But anyways, yeah, that's enough of that. Yeah, so let's get started. I was reading a bit about Minimax, just refreshing myself. So yeah, let's kind of open up the three things: Minimax, AlphaBeta, and Negamax. Okay, so Minimax is this is Minimax, right? So like everything is basically from the perspective of like kind of like the maximizing player, right? So the maximizing player is good, then like the value of the node is like from the like if it's like let's just say it's like between like negative, or never mind. Like whatever values we return, they're from the policy of the maximizing player. So the maximizing player basically like you recurse, you pass the turn to the other person. And then like each child basically, like the child is just like by executing the action, we get the child. And then for each of the possible moves we can make, we look at the resulting child state. And then we kind of call minimax again, except we kind of switch whose turn it is, because now it's the other guy's turn. Let's call maximizing player P1 and minimizing player P2. Then like we basically kind of did like it's a recursive process, and we kind of like flip whose turn it is. And then there is some depth, so we kind of decrement the depth where 0 is the base case, where we just return the perspective of the player 1. And then we kind of minimax it, and then we kind of get the value, and the values that this returns will be from the perspective of player 1, or let's call the maximizer, the alpha and the beta, or let's call the maximizer and the minimax, I guess. Keep use their terms. So then the maximizing player maximizes everything, and then the minimizing player just basically minimizes everything. And that's why the infinity signs kind of switch too. And that's it. Pretty standard minimax, right? Like, then there's the concept of alpha beta pruning, which I'll have to relook at because it's been a while since I've looked at this. But it's just an optimization. Like, it doesn't change any of the actual like the answers. Like whatever answers that like whatever result that this would return, like alpha beta would return the same exact thing, except it would just be faster, hopefully. It just uses pruning. But before we do that, let's kind of look at Negamax, right? So this is kind of like what happened, what we did in our MCTS by kind of looking at like this kind of like pseudocode, where it's like not this one, the search. Like we're returning negative we, and rather than like minning and maxing, we're only doing like maxing or like the UCB. So it's like purely max, and we're returning negative v. So like that's kind of like where negamax. What did I just do? Huh? Anyways, so that's what that does. I guess in here, rather than returning negative value, you're returning the value. So here, the value that you're returning is from the, I'm guessing, the perspective of like color is, so there's 1 and -1, and color is negated. So color is just kind of like whose turn it is, basically. It's, I guess, like the same Boolean of like false and true, where true means 1 and then false means -1. Like, so like negamax is the same thing as minimax, except like rather than kind of, it's just like kind of, rather than kind of like having like kind of like two blocks right here, where like these are both essentially like the same code, except like these signs get swapped and this max becomes a min. And like you kind of have, it's like min of a b is like negative max of negative b negative a, right? Like so you have like min of a. Okay, so it's like let's just like draw the whiteboard. Should we drink some water? Okay, so let's just say that like, so what am I trying to do? I'm trying to like kind of like you use this thing. Actually, I like to just like before let me just look at the actual pseudocode, right? Basically, like this compare this visually, like this compared to this, like it's kind of half the size because like rather than doing a min and a max, like we're iterating over all the children twice, but we're just kind of like doing that. Whereas like, and we're kind of like, how do we know which block to do? Well, it's either if we're minimizing or maximizing, and like that same kind of thing is passed in as the color, I guess. So, anyways, so if the depth is 0 or the thing is terminal, then we return the color heuristic value of the node. So basically this is like the negation of what we're doing here. Because like here we're returning from the perspective of the other person. Note we were getting negative. The state, this is because alternate levels from perspective of different players. So like here we're returning the value from the perspective of the other player. So like here this we're not doing it. Here the negation's pushed into here. It's basically the exact same thing. So here what they're doing is like, so what is function, like here's a function negamax, and what it returns is a value from the perspective of the player whose turn it is, and that's why when the depth is 0, we return like the heuristic value and multiply by 1 or -1. I see, so we don't want to use true or false because we want to actually like kind of use it as a as a scalar, as a scalar, or a just a scalar, a multiplier, a sign bit, so to speak, a sign bit. The sign of it, this could I would call this SIGN if I were. Anyways, I guess no, coloring is a separate like, and anyways, so the base case that like we've like kind of like exhausted, like we've hit the leaf node, or I mean, well, terminal is different too. I was gonna say if we've exhausted our depth, because we can't like, it's not tractable to like kind of solve the game, right? Like it's exponential. So like we fixed the depth. I think I did 3 last time. Again, our branching factor is 24. So like each time we're kind of like doing 24 times the work. Like the branching factors branches so much. I mean, yes, we have alpha beta, but anyways, that's beside the point. Still exponential. Like we know getting around that. So like we return the color times the heuristic value of the node. So the base case is, you know what? Like there's nothing more that to be done if we're terminal, or there's nothing more we want to be done. In either case, there's nothing we're gonna do. We just return the value. We just return answer. So this function returns like the value it returns from the perspective of the player whose turn it is, whose color it is. And then what we do is like we're kind of like doing a maximizing. When we do max, we always kind of set to -infinity because that's the smallest and anything is greater than that. So we're kind of maxing over, like we're considering all the moves, and then for all the resulting states of the moves, what we're doing is we're maximizing over, we're calling the same thing on the child. So we flip the color, do some bookkeeping for the depth, and then we call this thing recursively, and it recursively, again, what does this return? It returns the value from the perspective of that player. So we, by calling this, will get, it's called like, it's like the recursive leap of faith, so to speak. Like this thing will give us the answer from the perspective of the other player. Let's say player 2, like the player like who's like the other color, negative of color. But then since we got the perspective of that player, we have to negate that again to flip it back to our perspective. Or we could return negative value and kind of delete that thing. Then we maximize over that, and that gives us our value. So that's kind of like, that's negamax basically. But I want to see where this thing comes. Like, hold on, let me just... exactly. More precisely, the value of a position to player A in such a game is the same, is the negation value for player B. So like if it's -1, then it becomes 1, like the whole flipping thing. Like kind of like, this line right here is basically the same highlighted line is basically the exact same that like this is saying right here. But I want to see this, like where does this come into play, right? Let me actually like draw it out, the whole point of whiteboard, because I want to like kind of like, because this is like, if you have like, let's say A and B is like 3 and 5 or something, then that's like the min of 3 and 5 is 3. So like max if, well, I don't know why these are switched, like 3 and 5, -3, -5. Well, -3 is greater than -5 because that's how the number line is. So return -3. by max, then we negate that back to get 3. Okay, so let's just kind of see, like but why is it like min, right? Like, I guess because like here we're kind of like, because like the max case is pretty obvious. Hey, we're maximizing our value, but in the min case is like we're minimizing. Like it's like we're minimizing. It's like, why are we using like min instead of max? So won't we always want to use max? Like there's like some kind of like there's some kind of flipping going on, right? So anyways, like I mean, let's just kind of like see nega max. Like I want to kind of see this in action, because like this thing actually like reminds me of like De Morgan's laws too, where we're kind of like pushing like, it kind of like, if you're kind of like doing like not like let's say we have like min of a b, and we want to rewrite the min as a max, then like, or we want to like do like negative min of a b, which is basically going to be like negative of negative, or like, so negative min of AB will be kind of like max of like, and then we kind of like push. It's like De Morgan. It's like, what's De Morgan's law? Like you have like A or B, and you basically like negate that as like not A, like and like not B. And like the same thing applies for like if you swap the ands and the ors, like not A and B would be not A or not B. So it's like kind of like we're pushing it, we're kind of like distributing this, and like that basically toggles that from this, and like kind of it goes like the other way too. It kind of reminds me of that too. Like we have like min of like AB, and we're kind of like negating it, which would basically kind of like flip that, like the negation kind of flips over here and like toggles it to like a max, and then kind of like the negation kind of like goes here and here, and like negative A, negative B. So if min of AB equals that, then that without the negative equals that. And like this thing is kind of like what they're saying right there. But how is this relevant to like, how does it apply to this? Well, let's just say that like we're player 1, and then like everything is for like from, or like let's just pretend that we're player 1, and then, or we're some player, yeah, just color 1. Yeah, our color is 1, player A, player 1, A, B, 1, 2, true, false, 1, negative 1, different ways of saying the same thing, the maxer, the minimizer. So if we're like the player 1, and we're looking at all the children, and then we're kind of like maximizing, and then, well, no, we want to like see the case of min. Okay, so let's just say that we're player 1, and we can make some moves, and let's consider this move right here. Like let's call this like move 1, move 2, and move 3. So after moving 1, it's like the minimizer's turn, or let's just call this like player 1 and player 2. So player 2 can like, let's call this like 1, 1, 1, 2, and 1, 3. And let's say that like that's all our depth, and then like we hit like, and we get like we get like 3. Again, I'm not scaling mine between negative 1 and 1. I'm just kind of like using anything. And 7, right? So it's like, so all these levels, like these two are like player 1 levels, and it's player 2 level. So like if this gets 3, 4, and 7, right? Then for this player, like you're kind of minimizing like 3, 4, 7. We take the min of everything, and that would be basically like 3, because that minimizes everything. But rather than kind of like do a 3, like what Negamax does is like it would return 3. So like when we're doing the Negamax that they describe, we would basically, instead of like doing min of like min of 3, 4, 5, it's not doing a min, it's only doing a max. But what is it doing a max of? It is doing a max of the negation of, it negates all the values basically. It's maxing over the negations of everything else. So like it's either we're returning negative 3, negative 4 instead, or we're returning 3, 4, 7. and we're flipping the sign here. But either way, the sign's getting flipped. So like the sign that this is showing basically is from the perspective of the current player, like this thing. And then we can always max over things from our perspective. So from the perspective of player 2, this 3, 4, 5 is actually -3, -4, and -5. Because again, like we're seeing 3, 4, 7. Or actually, let's just make this a 5. Nice consecutive numbers. So then we have like 3, 4, 5 from perspective of player 1. But from player 2's perspective, it's actually -3, -4, -5. And then it's going to choose like this path right here. Like that's the thing that's kind of like what's interests it. In that, so then we'd get like -3 by like we want to max over that. But again, the min of this equals 3, and the max of that basically equals -3. And then of course we and these are not equal. There's a negation sign, and that's kind of like where this negative comes in. So yeah, I mean this basically checks out. This interplay of maxes and mins, like the mins becoming a max of the negatives, something like that. And then there's AlphaBeta pruning, which I'm sure this can explain. But right now, let's just kind of like do the negamax first, and then let's incorporate AlphaBeta after that. Okay. Right. Yeah, let's get started then. Status. Yeah, these weights. Yeah, I guess yeah, there's some weights that haven't been published yet. Declare, hit status. Okay. So you see a function called getRandomMove. Similarly, let's have a function. We can call this instead of getRandomMove, getMinimaxMove. MinMaxMove. Game state, and then move. And again, game state is wait, no, it's a block game state, right? Okay. So right now, let's just forget about the previous game state entirely. Let's just forget what the velocity is. Only do in terms of like the features for the current game state. And then we just post the move. But rather than do MCTS, we would call this get min-max move. And that just takes in the game state bot. And that's it. Of course, we need to return a move to get it to compile, right? So then that's kind of like, that's all the, I think that's all the scaffolding that we need. So now we have to do this, and then let's just open up GameState. I think it's like GameState dot. Or actually, no, it's in front-end client. That's a lot of stuff. Oh wow, we have some C4 stuff that's copied in there. Yeah, those should be deleted. Just GameState.ts. So is P1 turn, right? So that's kind of like what we need. Okay, now let's pretend that we have a function called like eval or heuristic. And this heuristic returns a guess an educated guess that evaluates the game state from the values to game state. Perspective of whose turn it is. Okay, so let's just treat this as a black box that returns a number. And when what should the result be? Like, should we keep it consistent as should we keep it consistent from -1 to 1? Actually, this doesn't matter. It could just be any number, right? Like, well, no, if it's 0 to 1, then like negation doesn't really do much. So I guess -1 to 1 maybe. Oh, whatever. It just returns a guess, some number. That's fine. So is P1, and then let's kind of like have a let's have like this. Let's have like another thing called depth. But actually, no, we should just pass it in there. Well, what's the or negamax? Depth, no depth color. Well, color is baked into the node, like whose game state dot is P1 turn, whatever. More like depth left, or like left, or whatever depth. First thing first, let's do the game over check, right? If state dot so we're first checking if it's terminal or not. Status is not equal to Okay, we have to import that also. We're exporting the enum right here as game status. Game status. Actually, since there's no game status currently in our BumperCoins, I think it's called game outcome, we can just straight up use that. Actually, no, we should mention that's bot. Just to get it to compile, return 0. 0. Zero's negation is 0, so it's clearly a draw. Okay. So so if it's I can consolidate this as a ternary. Else if the player won, then actually no, let's undo everything. Or redo everything. Oh, whatever. No. If so, like P1 1. What did I call it here? Boolean. So player 1 is that. Oops. Just like that. P1 1 equals as P1 turn. Then was it max and min again? Sorry about that. Plus Sorry about that. Positive infinity, okay. Okay. So now, so here we're handling so like if it's not ongoing, that means the game is ended. So then there's three cases. Either it's draw, player 1-1, or player 2-1. If it's a draw, we return 0. And then if player 1-1 equals to its P1 turn. So let's say that player 1 did win, and this game state is for player 1's turn. So that's true equals true. Then, like, these are in alignment, then we return positive infinity, or else, since these are incongruous, so it is, I mean, if they're both equal, that means player 1 won, and it is player 1's turn, like, that's the outcome, so that means it is positive infinity, which is, like, really good. It's really good for bot game state, which is, wait. No, wait, no. Are we going to return that, or are we going to negamax it in return from the perspective of the other player, like we do in an existing MCTS search? I guess we'll stick to the Wikipedia convention because, like, at the top level, we don't want to do negation, right? Because, like, for MCTS, at the top level, like, yes, we get a negative value, but we actually ignore that. At the very top level, we only look at, like, the children and look at their visit counts and normalize them by the total number of visits, which is equal to the Monte Carlo simulations. And then we got to extract the policy. But here at the top level, which we do it right there in this bot move, game state. I have to make sure the bot state is player 1 turn is false because player 2's turn the bot. Let's check convert game state does that. It has to do that, right? Yeah, make it bot's turn. Precisely. Actually, wait, in prev game state, technically it should also, like, switch this to, never mind, because it's never really used. It's only used, like, this whole previous thing is only used to get the coin positions. It doesn't consider the turns in the past historic states. Anyways, back to where we were here, line 30. So let's just consider all four cases, right? If it is player 1's turn, let's consider the two is player 1 cases, right? Then the duel has to be symmetry, so we don't have to care about it. So let's say that this thing is for player 1's turn. That's true, and player 1 won. Great, so then we return positive infinity. That makes sense. Now it says player 1's turn, but then player 1 lost, which means we return negative infinity, because this is false, so we return negative infinity. Yes, well, let's kind of specify who returns who, right? What this returns. Returns are evaluation of oh wait, but this is returning a move. Okay, we have to make it return a number. Returns are evaluation of the game state, the bot game state, or actually let's just kind of return a number and a move. Let's return a number. Let's return a number, and then let's return the. Wait, hold on. Turn a number. And return a move. Turns our evaluation of the bot game state. Turns evaluation of the bot game state and turns the pair perspective of move to play. So then we can call get min max move. Here, we have to do the second out, like, and that, like, because, like, the bot move actually is, wait, this is not move, this should be bot move. Oh, wait, no, yeah, it's called bot move. Just like that, right? So SP1 turn, bot game state that SP1 turn, and then I have to use the restroom. I'll be right back. Yeah, I'll be right back. Alright, I'm back. Yeah, where was I? Bot move, we returned it. Oh, then we have to you have to propagate those things. It's called undefined. Or actually just... Because at the top level, when we call this in here, we're not gonna ever call this if it's terminated, if the game's over. Like this, whatever this game state bot is, like its game status will be ongoing. Like we would never like ask the bot for a move to say, "Hey bot, give me a move," if the game ended already. That's no, that's just a precondition. So like we don't have to really worry about undefined. But maybe I should specify the type there. So then here, when we're kind of doing it, because like we're basically saying, hey, it's not undefined. Okay, so that's the terminal case, and then if ddef equals 0, instead of get min max, let's do a search. Sorry, not recording. Wait, what? Status. Let's kind of replace that with negamax. 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 Oh, that's all. Okay. It's right here, negamax. Then just return the heuristic. This whole color times a heuristic thing is going to be baked into the heuristic function. On terminal node, again, like this is P1 term, like it's baked into what you return. So I guess here the terminal value of the node, like the terminal value is kind of baked into the heuristic. So I guess like this logic that we're doing here, I guess maybe it should have been in the heuristic itself. But I guess this is kind of more upfront, like, hey, we're done. It's more definitive. Heuristic is more like the guess. It's not like it's only for ongoing that we need a guess. Like some fuzziness. We're definitive if the game's over. It's positive infinity, negative infinity. Okay, that looks good. Else. Okay, so we need to copy that stuff from like net.ts and get policy and move. Like we need like the logic where we generate all the possible moves, right? Let's just try to get this to compile and then do it later. So like we had like in connect 4 was called game state.get legal moves, but then we deleted that and we kind of did everything, and I think in this function here, like, yeah. To do generate the legal move. So we need to consider the numders too as a generate the coins. Look at BumperCoins bot net dot net dot get policy and value, right? Actually, maybe this whole function we should have been doing in the BumperCoins bot repo, so that like, okay, I guess in the future what I'll do is I'll kind of take all these changes and I'll put it there, just like we have like a do MCTS from BumperCoins bot. I think we should also put in Negamax in BumperCoins bot. Actually, I think that's the right thing to do, in fact. Actually, well, this is more of a, this whole Negamax will AlphaBeta to be added. We'll have to add like an AlphaBeta parameters to this too. But anyways, like, I mean, it's more of a one-off thing. Just, hey, here's a novelty Minimax bot. So to generate legal moves for all coins, look at BumperCoins bot, net get policy and value. But for now, let's just have this empty list and just get it to compile, you know, like let, like the word legal means whose turn it is. Like we can't make moves for other players' coins. Then for let move of moves. Let's pretend that we have a function here. Actually, no, we have game state that apply move, right? So then let child bot game state equals to the bot game state dot clone, just like we're doing an MCTS in BumperCoins bot. Then child dot apply move. So then here we basically like get the child and we just kind of do it, but then we have to flip it. Okay, yeah, and then toggle. Okay, yeah, fine. So now, oh yeah, we have to do let eval, put this in the very top after base cases, equals to, again, since we're maxing, we have to make negative infinity as like our best so far. Yeah, negative infinity. We're maxing. Let best move, bot move. Actually, no, it's a best move because like human. Never mind. It's best move. Yeah, this whole kind of, yeah, I think we should have done all this work in the BumperCoins bot repo, not in this one. Best move, yeah, I feel that that's the correct thing to do. Bot move equals defined. Let value from our perspective. Equals to -1 times and then whatever, right? And like recurse. Negamax of something, and then if this thing is greater than the best move, or the eval, or max eval, or max value. Eval and value are like, you just need a VAL is a U, yeah. So if we've surpassed it, if that, and again, initially it's negative infinity, so we always would. No, not always. Let's just make it greater than or equal to. And then just set the best move. And that would just be this move right here. At the end, what we want to do is return the eval and the best move. Just like that. So all that's left is to fill in what's in here, right? That's it. And this would be the child game state and the def -1, right? In apply move, we'll toggle the whose turn it is in the game state. Okay, so let's just kind of save that. See if it compiles. Oh, this is Frankton. I have to run the whole thing. Okay, some errors. 41, 42. 41, 42. Oh, that's a Java thing. Okay, 3 errors. Okay, let's make the undefined. This is line 43. Actually, you know what? Let's just pass it to itself. I mean, yeah, we could just put it in a parameter here, like in the negamax argument, but we're all, no, let's just do it itself. Just get the compiles to work. That's all. Actually, let's keep it undefined. Next error is line 45. Oh yes, we have to index into it. Of 0, the value, because 1 is the move. Okay, 76, negamax. 76 and depth. Okay, so 76. GG, or here. And then let depth number equal to 3. I make move, bot makes move, human makes move, bot makes move. So we're kind of like letting the bot get more hits in, kind of. That's why I choose an odd number. That should be all the errors. Okay, good. So it compiled. Okay, so I think that's a good stopping point for now. I have to do the to-dos and then Minimax should work. And then we're gonna augment, like we're just gonna make AlphaBeta, we're just gonna add AlphaBeta pruning to this. And then, and we need to like, our main to-dos right now are, well, first of all, AlphaBeta. And then second of all, we have to adapt it to Negamax. And then we have to, what are the to-dos? There are like two to-dos. One of them is like generate the moves. But again, that's pretty trivial because like we've done that before. And then the only hard thing is the heuristic function, which is to-do. Right now we're returning 0. It's a skeleton, but we have to actually implement that. So main thing, heuristic. Second, do the moves, generate the moves. And then third, convert it to AlphaBeta pruning or add in AlphaBeta pruning. And finally, I guess optional, we can take all this and we can migrate it into the BumperCoins bot repository, which we were originally working on anyways. So that way we don't have to do all these imports as bot move. We can just work with move. We can work in that world and just let that world export like a global function, export that thing to the module, whatever, just export it, just like we have do MCTS, which kind of, it's like, yeah, like just kind of keep everything in the bot world, like don't pollute it with our world and just only expose an interface of these exported functions, like do MCTS for us to work with in the BumperCoins world. So that's the idea. So finally migrate to BumperCoins bot. So I think that's what's left. So then next time what I'm going to do is before like kind of like implementing all the to-dos, I'll first start off with the AlphaBeta pruning, adding on to it. Because yeah, I feel kind of tired and I want to go outside for a walk. Maybe I can kind of like briefly discuss alpha. Just like look at this picture. I mean, pseudocode. Actually, I'll just stop for now. And then next time we'll do AlphaBeta pruning onto this and then do the to-dos. And then I might just move it onto the bot repo off stream or we'll see. But anyways, actually we could just forget about that. But the thing is that, yeah, those are the to-dos. So that's what we'll do next time. Said that will be all for now. Wait, did I negate it? Yeah, no, I think I did -1 times. Okay, that's all for now.